Good morning, students. Today, today I'm going to talk about C programming language. We'll start with the first concept, basic structure of C program. So before starting with the basic structure of C program, let us talk about the overview of C program. Let us talk about a brief history of C programming language. C is a strange and a strong name for programming language. The root of all the modern programming languages is ALGOL, introduced in the early 1960s. ALGOL was the first programming language to use a block structure. Although ALGOL never became popular in USA, it was widely used in Europe. ALGOL gave the concept of structured programming to the computer science community. Okay. In 1967, Martin Richards developed a language called BCPL, Basic Combined Programming Language, primarily for writing system software. Then in 1970, Ken Thompson created a language using many features of BCPL and called it as B. B was used to create early versions of Unix operating system at the Bell Laboratories. Both BCPL and B were typeless system programming languages. C was evolved from ALGOL, BCPL, and B by Dennis Ritchie at the Bell Laboratories in 1972. C uses many concepts from these languages and added the concept of data types and other powerful features. Since it was developed along with the Unix operating system, it is strongly associated with Unix. So this operating system, which was also developed at Bell Laboratories, was coded almost entirely in C. Unix is one of the most popular network operating systems in use today and the heart of the internet data superhighway. So for many years, C was used mainly in academic environments. Okay, during 1970s, C had evolved into what is known as traditional C. The language became more popular after the publication of the book, The Programming Language by Dennis Ritchie and Brian Kernighan. The book was so popular that the language came to be known as K&R-C among the programming community. The rapid growth of C led to the development of different versions of the language that were similar but often incompatible. So to assure that the language remains standard, in 1983, American National Standards Institute, ANSI, appointed a technical committee to define a standard for C. The committee approved a version of C in December 1989, which is now known as ANSI C. It was then approved by the International Standards Organization in 1990. This version of C is also referred to as C89. During 1990s, C++ language, entirely based on C, underwent a number of improvements and changes and became an ANSI bar ISO approved language in November 1977. So apart from C89, there are also versions called as C99. Okay, so a brief history is during 1960, ALGOL came into picture. 1967, BCPL. Okay, BCPL, Basic Combined Programming Language. Basic Combined Programming Language. B in 1970. Traditional C in 1972. K and R. Brian Kernighan and Dennis Ritchie, K and R C in 1978. ANSI C in 1989. ANSI bar ISOC in 1990. C99 in 1999. This is a brief history about C programming language. Second is, let us also talk about the importance of C. The increasingly popularity of C is probably due to its many desirable qualities. It's a robust language whose rich set of built-in functions and operations can be used to write any complex program. The C compiler combines the capabilities of an assembly language with the features of high-level language. Programs written in C are efficient and fast. There are only 32 keywords in ANSI C, and its strength lies in its built-in functions. Several standard functions are available which can be used for developing the programs. C is highly portable. That means the C programs written for one computer can be used, can be run on another with little or no modification. Portability is important if you plan to use a new computer with a different operating system. C language is well suited for structured programming, thus requiring the user to think of a problem in terms of function modules or blocks. Another important feature of C is its ability to extend itself. A C program is basically a collection of functions that are supported by the C library. Okay. Now, let us talk about the basic structure of a C program. Okay. It's as per your syllabus. This is the first concept. Having discussed about the history of C programming language, let us begin with the basic structure of C programs. A C program can be viewed as a group of building blocks called functions. A function is a subroutine that may include one or more statements. Okay. Figure given in the slide is an overview of C programming language. First, it includes the documentation section. Documentation section consists of a set of comment lines giving the name of the program, the author, and other details, which the programmer would like to use later. Okay, documentation section, okay, includes comments, statements, anything within. Comments like in C, they'll start with, we'll going to write the comments in between /* and ends with */. So anything written within these becomes a comment. Comment are not executable statements. Okay, it's option. It's an option to include. You can either include or you can not. But inclusion of comments, inclusion of the documentation section enhances the elegancy of your program. You can able to understand your program later, or program written by you. I mean, your friends or others can easily able to understand your program if you have written the purpose of each statement, or the time, the date, the purpose of the program if it is written using the comments. Then the second one is the link section. The link section provides instructions to the compiler to link functions from the system library. I mean, we will going to use statements like #define, #include stdio.h. Okay, #include stdio.h, and we will come across statements of that kind like #include conio.h. Okay, these are some of the examples. Link section provides instructions to the compiler to link the functions from the system library. The definition section defines all the symbolic constants. Okay, we will going to talk about the symbolic constants, and example for the definition section is, for example, #define, 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 DEFINE. Okay, then one space, one character space, pi space 3.14. It's an example. It's an example for definition section. This is not the only one what we can use. You can use any number of statements of this kind. For example, #define space capital letter pi space 3.14. So wherever in the program pi appears, pi is replaced with 3.14. Okay. And one more example, for example, #define space ABC space 100. So wherever in the program ABC appears, ABC is replaced with 100. So these are all the examples for the definition section. Then comes the global declaration section. There are some variables that are used in more than one function. Such variables are called global variables. Okay, in C program, you can include many functions. Okay, so you'll come to know what are global variables later. But if you want the variables to be used and accessed and seen by all the functions of your program, then the variables must be declared in the global part before the main function starts. Okay, the variables that are outside of all the functions are called by the name global variables. So then comes the main function section. Main function section. Main function section, look at, includes declaration part, okay, and executable part. Declaration part declares all the variables used in the executable part. There is at least one statement in the executable part. These two parts must appear between the opening and the closing braces. The program execution begins at the opening brace and ends at the closing brace. The closing brace of the main function section is the logical end of the program. All the statements in the declaration and executable parts end with semicolon. The subprogram section contains all the user-defined functions that are called in the main function. The user-defined functions are generally placed immediately after the main function, although they may appear in any order. All the sections except the main function section may be absent when they are not required. Okay. Programming. So this was explained. Documentation, I'll repeat again. Documentation section consists of a set of comment lines giving the name of the program, author. You can include many more. Purpose of each line. You can also include comment lines at the end of each line of your program. Link section provides instruction to the compiler to link the functions from the system library. The global declaration section contains variables that are declared outside of all the functions. Every C program must have main function section. The subprogram section contains all the user-defined functions that are called in the main function. Okay, let us talk about the programming style. Unlike some other programming languages like COBOL, Fortran, etc., C is a free-form language. That is, the C compiler does not care where on the line we begin typing. While this may be a license for bad programming, we should try to use this fact to our advantage in developing the readable programs. Although several alternative styles are possible, we should select one style and use it with total consistency. First of all, we must develop the habit of writing programs in lowercase letters. C program statements are written in lowercase letters. Uppercase letters are used only for symbolic constants. Braces group program statements together and mark the beginning and the end of the functions. A proper indentation of braces and statements would make a program easier to read and debug. Note how the braces are aligned and the statements are indented in every program. Okay. C is a free-form language. Okay. We can group the statements together on one line. For example, the statements A is equal to B, X is equal to Y plus 1, Z is equal to A plus 1, okay, can be written on one line as A is equal to B, X is equal to Y plus 1, Z is equal to A plus, that is 1, it's been misspelled, okay. So you can group the statements separated by semicolons, okay. The program main and opening brace and closing brace. Within that, hello C. This is a familiar small program, because the first C program of any student normally we call as hello C or hello world. Okay, hello world. Hello C is, it can also be written in one line as main. Look at main, main, opening and closing parenthesis, then opening brace, printf. Printf is a function, okay, available in C programming language. Within parenthesis, within double quotes, hello C is written. So what is printed on the screen? Output of this program is hello C. Hello C is the output of this program. Okay, this is a small program. Okay, we started writing small programs. Then now let us start talking about executing a C program. Okay, executing a program written in C involves a series of steps. The steps are, the first step is creating the program. Second step is compiling the program. Third step is linking the program with functions that are needed from C's library. And the final step is executing the program. Look at the process of compiling and running a C program. Figure illustrates this concept, the concept of compilation and running a C program. It illustrates the process of creating, compiling, executing a C program. Although the steps remain the same irrespective of the operating system, system commands for implementing the steps and conventions for naming files may differ on different systems. Okay, look at the steps. System ready, and once the system is ready, enter the program. Okay, program code. Okay, you're going to write the program, enter the program, then it becomes source program. Edit the source program using an editor. Okay, there are different types of editors available. For example, in Unix, VA editor is available, and gedit is one more important. There are many editors available. Okay, and different operating system, different. Then edit source program. Once the program written by you, the program written by the user, it's normally called by the name source program. Once the program is written, okay, compile the source program. Compile the source program using a C compiler. Okay, the process of compilation converts the program written in high-level programming language like C to its machine equivalent language. Okay, once compiler is a translator which converts the program written in high-level programming language to machine equivalent form so that the machine can able to understand the program written by you. Here, in case of C programming language, we are making use of a C compiler to compile the source program. Okay, so once the program is compiled, if your program is error free, then its equivalent .obj code is going to be created. Or if your program contains some syntax errors, okay, mistakes like misspelling. For example, in one of the previous slides, we have seen printf. Instead of writing printf, if you have written just print, okay, it will not be compiled to its equivalent object code. Misspelling, misplacing the braces, there must be the number of openings should be equal to the number of closings. Normally we say like if there is an opening brace, there must be an equivalent closing brace. If there is an opening parenthesis, there must be an equivalent opening parenthesis. And if you have missed semicolon, colon, okay, double quotes, let us say you have used opening quotes and you have not closed it properly, okay, all this will become syntax errors. If your program is syntax error free, then its corresponding .obj code, machine equivalent code, is going to be created. If your program contains errors, then look at the arrow from syntax errors to back to edit the program. There is an arrow going back. Okay, so again edit it, edit the program, correct the mistakes, recompile your program. Okay, again, if your program is error free, then .obj object code is going to be created. Once the object code is created, link the object code with system library. Okay, then it becomes executable object code. Then execute the object code by giving the input. Okay, logic and data errors. If there are any Once the program is executed, if there are any logical errors or data errors, then again, you need to go back to your program. You need to re-edit the program, again recompile the program, then check for the syntax errors. Again, if it is error-free, its corresponding object code is created, link it with system library, you'll get executable object code, then execute the object code, again check for logic and data errors. Okay, again, if it is logic and data errors free, then you'll get the correct output. Otherwise, again, you'll have to go back to the editor. You'll have to go back to your program, re-edit, recompile. So if you make any changes to your program, you need to recompile. Okay, so if you have not changed your program, once if you think your program is correct, input can be provided, then output comes. And if you make any changes, you need to recompile your program. You need to make these changes again and again. Okay, so the process of compilation and running a program is shown in the figure. This is also called by, this figure is also called by the name, like you can also call it as a flow chart. Flow chart and algorithms are very, very important before writing the C program. Probably we will also talk about algorithms later. Okay, flow chart, it's a pictorial representation of your program. Before, it's like a blueprint of your home. Okay, it's like it gives us where the program is starting. Okay, although the flow chart here given here, it's telling us the process of compilation and running a C program. Flowcharts can be written for each single program separately. So it tells us where the program is starting, how the data is flowing. Okay, what is the logic of the program? We can able to understand the program very easily. Once the flowchart is written, then it can be converted to a C programming language. You'll come to know what is the logic, how the data is flowing, what is the input, what is the expected output. You'll get all this information from the flowchart. So you'll have to write either flowchart or algorithm. Algorithm is one more important way of expressing a program before writing the actual program. Algorithm is a step-by-step process, okay, of writing the program. It's not a direct solution. Algorithm is not a direct solution. Okay, it's a procedural solution. Flowchart is a pictorial representation. Okay, look at the arrows are look at the flowchart. The arrows are used, rectangular shapes are used, a rhombus is used. So I'll also talk about the different notations used for writing the flowchart, for input, for executable statements, for checking the condition. For all this, there are different notations. Okay, used. Probably in one of the next classes, I'll also talk about flowchart and algorithm in detail. Okay, but for now, this is how we compile and run our program. Okay, so let us also now talk about creating the program. Creating the program. Let us talk about the simple. Let us start with so once we load the Unix operating system into memory, the computer is ready to receive the program. The program must be entered into a file. Okay, the file name can consist of letters. The file name can consist of letters, digits, and special characters, followed by a dot and a letter C. Examples of valid C programming language files are hello C, hello.c. Hello is the name of the program. .c means it's an extension. It gives us, it tells us that this is a C programming language file. Program.c is one more example. Program is the name of the C programming language file. .c is the extension. The file is created with the help of text editor, ed or vi. Okay, you can use any other editor, okay, for that matter. The command for calling the editor and creating the command for calling the editor and creating the file is ed. For example, if it is ed editor, then the command for calling the editor and creating the file is ed space file name. If the file existed before, if you have already created the file, it is loaded. If it does not exist, the file has to be created so that it is ready to receive the new program. Any corrections in the program are done under the editor. The name of your system's editor may be different. Okay, please check your system manual. When the editing is over, the file is saved on disk. It can then be referenced anytime later by its file name. The program that is entered into the file is known as the source program, since it represents the original form of the program. Compiling and linking. Let us talk about compilation and linking. Compiling the program and linking the program. Let us assume that the source program has been created in a file named ebg1.c or hello.c. Let us also talk about hello.c. Okay, let us assume that the source program has been created in a file named hello.c. Now the program is ready for compilation. The compilation command to achieve this task under Unix is cc hello.c. Then the source program instructions are now translated into a form that is suitable for execution by the computer. The translation is done after examining each instruction for its correctness. If everything is all right, the compilation proceeds silently and the translated program is stored on another file with the name hello.o. .o stands for it's an object code. If the compilation happens smoothly without any syntax errors, then hello.c is converted to hello.o. This program is known as object code. Linking is the process of putting together other program files and functions that are required by the program. For example, if the program is using exp function, exp opening parenthesis and closing parenthesis, like in main function, main opening parenthesis and closing parenthesis we have written. For example, if your program is using exp opening and closing parenthesis, brackets you can for time being understand. If your program is using exp function, then the object code of this function should be brought from the main library of the system and linked to the main program. Under Unix, the linking is automatically done if no errors are detected when the cc command is used. Okay. Compilation cc space hello.c. It is converted to its equivalent object code. Then it is linked with the system library. For example, if you are making use of any mathematical libraries like expression, sine, cos, then you need to bring it from the math library of the system and link to the main program. If any mistakes in the syntax and semantics of the language are discovered, they are listed out and the compilation process ends right there. The errors should be corrected in the source program with the help of the editor, and the compilation is done again. The compiled and linked program is called the executable object code and is stored automatically in another file. Okay. Note that in some systems, we use different compilation commands for linking the mathematical functions. For example, the common syntax is CC. CC stands for, this is the compilation command, CC space file name of the file. For example, let us say if it is hello, then it is hello.c, CC space file name space hyphen, okay, LM, okay. It's a mathematical library, LM. If you're using any mathematical functions in your program, then while compilation, you need to include this one, and it's different from system to system. Then executing a C program, okay, executing the C program. Once the program is compiled and once your C program is linked, execution is a simple task. The command a.out will load the executable object code into memory and execute the instructions. Okay, whenever you type a.out and press enter, okay, the object code is loaded into memory for execution. Then the system, then your CPU will consider your program for execution. Only then it will consider for it will be considered for execution. Okay, the next one, you can create you can also create your own executable files. You can also let us talk about multiple source files. To compile and link multiple source program files, we must append all the file names to the CC command. Okay, if you are compiling and linking multiple source program files, then we must append all the files names to the CC command. For example, CC space file name 1.c, okay, space file name 2.c, etc. These files will be separately compiled into object files called file name -i.o and then linked to produce an executable program file a.out as shown in the figure. Compilation of multiple files. Okay. .c. Look at here. Whenever you are compiling three different programs, their equivalent object code files are going to be created with .o, and .o, compiler and preprocessor. Okay. Then you will get a.out, which is also linked with the system library. Okay, this is all about compilation of multiple files. Compiler and preprocessor directives. For example, in the beginning, I have discussed documentation section, link section, definition section, global declaration section. Okay, hash include stdio.h, hash include conio.h. They are also called by the name preprocessor directives. Okay, preprocessor directives. In MS-DOS, the program can be created using any word processing software in non-document mode. The file name should end with the characters .c, like program.c, pay.c, etc. And its compilation and execution, it's different from the systems what we have discussed. Okay. So today in this class have talked about C programming language, its overview, it's important, okay. So importance of C, uh, main within opening and closing parenthesis is the function name, then opening brace is the start of the program, then with inside opening and closing brace the program includes declaration part and executable part. Once the brace ends, it means that is the logical end of the program. Okay, so and as far as the main function is concerned, you can write it as main. Okay, by default, a program, a function will going to return a value. Okay, you're going to learn about these things whenever we continue our discussions in future classes. Main program by default, like a function returns integer type of value. Um, that and you can also write int main, void main. Void means it returns nothing. It returns nothing. Or main void main void, int main void. The empty pair of parentheses. If you have just written main, opening and closing parentheses, the empty pair of parentheses indicates that the function has no arguments. Okay, within the opening and closing parentheses, if you have written anything, that then it's called as an argument. The empty pair of parentheses indicates that the function has no arguments. This may be explicitly indicated by using the keyword void. Okay, if inside opening and closing parentheses, if you have not included any argument, it can be indicated using the word void. Void means nothing. We may also specify the word keyword, okay, int, okay, or void before the word main. The keyword void means that the function does not return any information to the operating system, and int means that the function returns an integer value to the operating system. When int is specified, the last statement in the program must be written 0. Okay, for the sake of simplicity, we use the first form in our program. These are some of the sample programs. Okay, with this, so some of the key concepts used are hash define. Hash define is a preprocessor compiler directive. Printf is a predefined standard C function that writes the output to the std out. It's a standard output. Scanf is a predefined standard C function that reads formatted input from stdin. Program is a sequence of instructions written to perform a specific task in the computer. Okay, so along with this recorded information, you'll also get some notes and multiple choice questions. Okay, please go through the textbook. ANSI programming in ANSI is the textbook mentioned for. It's one of the important textbook mentioned in your syllabus. 7th edition, programming in ANSI. Programming in ANSI. It's the 7th edition. Author is E. Balaguruswamy. Programming in ANSI. Author is E. Balaguruswamy. You can refer this textbook. Okay. It's mentioned in your syllabus. For C programming language, you can refer this and other textbooks mentioned in reference and textbook section. Okay. So if you have any doubts, you can contact me anytime or whenever we go through the syllabus again. If time permits, then you can ask me or you can just text me either through a normal message or WhatsApp. If you have any doubts, you can contact me in any form. Okay, so I'll continue. I will continue with the next topics in the next class. Okay, thank you for listening to me, and let's end our meeting. Thank you.